Okay, we're going to look at key attributes of the quadratic equation. You know that the standard form, ax squared plus bx plus c is equal to 0. Okay, you need this first term to be there. You need that x squared term because that's what makes it quadratic. In fact, this is called the quadratic term. Without it, you just have bx plus c, that'd be a linear function. If you had x cubed, that's a different function altogether, a different polynomial. So you need the x squared term. That's the highest exponent you can have. It can be by itself. You don't need this one and you don't need that one, but you definitely need that one for it to be a quadratic. And we'll look at those in just a minute. Okay. The c term is the y-intercept. It's a constant. It'll be a number all by itself, or it might not even be there, which means it's 0. Okay, but it's the y-intercept. It's where the parabola crosses the y-axis. It might be right evenly. It might be right in the center. It could be on one side. There's a y-intercept. It could be on the other side. It could be over there. Okay, so it doesn't matter. It's just where the y-intercept is, where the parabola, the curve of the quadratic, crosses the y-axis. Now, the important thing, going back to the to this a term right here, the coefficient in front of the x squared term. Okay, it's important. If it's positive, the parabola opens in the upward direction. If it's negative, it opens up in the downward direction. So you can tell a lot by looking just at the equation on which way the parabola opens and where the y-intercept is. Okay, and this term here will give you a little more insight. I'll go into that in just a second. Okay, but the important thing is, does it open upward or downward? If it's positive, it opens upward. If it's negative, it opens downward. Look at the y-intercept. That's where the parabola crosses the y-axis. It's that simple. Okay, so I'm going to put the most simple quadratic in here. Y equals x squared. Okay, that's the most basic quadratic you have. The b term is 0, the c term is 0, and the a term is 1. So it's y equals 1x squared. Okay, and it's that simple. Now, what if I just add a number to it, plus 4? Notice it just moved it up 4. It's because the 4 is by itself. It's not 4x, it's just 4. So the b term is 0. So it's 1x squared plus 0x plus 4. We know that that 4 is the y-intercept, and sure enough, it's the y-intercept. What if it did minus 2? Minus 2 is the y-intercept. So if there's no middle term here, if there's no x term, then basically your parabola is centered on the y-axis. The y-axis is the axis of symmetry. Okay. Now let's look at, what if I put 2x? Okay. Now notice I didn't put anything for c, so it's assuming it's 0, and you can see the y-intercept is 0. But notice how the whole parabola is moved to the left of the y-axis. The axis of symmetry is negative 1. What if I put plus 10x? Okay, it's still moved to the left of the y-axis, and now your axis of symmetry is here. It's negative 5. Okay, what if I put y equals minus 2x? Notice how it's moving to the right a little bit. Minus 5x. It's moving to the right. So what this, and if I put in a y-intercept term, right now it's 0, so plus 2. There it is, it's plus 2. It just moved the whole thing up 2. Okay, so what you can gather out of this middle term If the a term, in other words, the number in front of the x squared, which in this case is positive 1, so it opens in the upward direction, if that's positive and the b term is negative, it shifts it to the right of the y-axis. Okay. If I make this positive, it shifts it to the left. Now, what if I put a negative sign in front of here? Okay, now it turned it upside down, and we knew it would do that. The y-intercept is +2, which it says right there, and there's 0, 2. But now, when you make this middle term positive, it moves it to the right, whereas when it was facing in the upward direction, it moves it to the left. So that's going to take a little bit of practice to understand that concept. So if the a term is positive and the b term is positive, it moves it to the left of the y-axis. If the a term is negative and the b term is positive, it moves it to the right of the y-axis. Okay, and it works the exact opposite. If I put a term positive and b negative, it moves it to the right. And if I have negative, negative, it moves it to the left. Okay. So if you understand those concepts, basically, if I give you the equation, and let me get rid of this whole equation altogether, and I'm going to write one in. If I just say negative 2x squared plus 4x minus 3, you can say, okay, the y-intercept is at -3, which is about right there. This is negative, so that means it's an upside down U. It's going to look like this. And this is positive, which means it's going to be right. It's moved to the right of the y-axis. So it should look something kind of like this. You know, I don't know if the points are exact. You can figure that out with other means. Like if I do the axis of symmetry, which you learned in a previous video, minus b over 2a. B is 4. It's b, so minus 4 over 2 times a, and a is -2, so it's 2 times -2. So it's -4 over -4, okay, which is 1. So the axis of symmetry is 1, which is like right there. So I really misdrew this particular curve here. Change the color to red. So if this is the axis of symmetry, so then that means it's going to come up across the y-axis, and this axis of symmetry is going to be right in the middle. So it'll look something like that. And you can figure out the vertex, the y value of the vertex. You know the x value because that's just the axis of symmetry. So you know the x value is -1 of the vertex. The y value, you plug in -1 to x and see what it calculates out to be. -1 squared is +1 times -2. It's -2. -1 times 4, okay, is -4 and -3. Okay, let me go back and fix what I just said. Okay. Even though I wrote down -1, that should be +1. We know that because I just drew it on here right there. And -4 over -4 is +1. Okay, so you put in +1, get rid of these numbers here. Okay, +1 squared times -2 is -2. Positive 1 times 4 is positive 4, so negative 2 plus 4, and then minus 3 from over here. So negative 2, negative 3 is negative 5, plus 4 is negative 1. Okay, so that means the y value is negative 1. So the vertex of positive 1, negative 1, which would be about right there. So I kind of misdrew the whole thing, but I was just guessing. I was just kind of guessing. So it's going to come up like this, go hit negative 1, and then come back down again. Okay, see that? But that's how you can do that. That's how you can at least get a lot of information just by looking at the equation. But I didn't use a calculator to do any of that. And if I put this in the calculator, let's see, we got negative 2x squared plus 4x minus 3. And there we go. It's a little more cleaner than my drawing, but there it is. Okay. And that's really how you do find out the attributes of particular systems like this when you're given drawings, when you're given equations, when you're given, if I do something like this, and they'll say, which one of the following equations does this correspond to? Okay, well, you know that the y-intercept is right there. And on this scale, that's a 7. So whatever equation you get, it's got to have plus 7 at the end. You know this is upside down. So whatever is up front has got to have a negative sign in front of it. Okay? And you know this is shifted to the left. So whatever the middle term also has a negative sign in front of it. Remember, if it's upside down, then that means that the A term is negative, and if it's to the left of the y-axis, that means the B term is also negative. If it's right side up, that means the A term is positive, and if it were to the right of the y-axis, it would be negative. If it were to the left, it would be positive. So they work kind of just the opposite. But just from seeing the drawing, you can get, the y-intercept, you can get the axis of symmetry just by kind of drawing in there. You know where the vertex is, it's right here. You know where the x-intercepts are. So it just depends what they ask you. If they say, what are the x-intercepts? There they are. Say, what's the y-intercept? There it is. They say, what's the axis of symmetry? There it is. They say, what's the vertex? Then the vertex is just the axis of symmetry. It's the x value. And then the maximum, in this case, because it's upside down, is the y value. Be there. Okay, so you can get a lot of information and determine which equations go to which graphs or which graphs go to which equations without ever using a calculator. Of course, a calculator will always help. If you have a calculator available, that's probably the easiest way, especially with multiple choice. Okay, but I've shown you everything other than to confirm something. I've shown you how to do this without using a calculator, and that should really do the trick.